Hello and welcome to the second part of PSV sizing. In this lecture, I want to just focus on the vetted fire case, and we will discuss how to find relief load within these cases and determine how to find it out if fire is applicable for our case or not. So initially, we need to find, clarify unvetted and vetted fire scenario. Then I want to discuss just focus on the fire scenario within this lecture. So typically, if the vessel have a liquid within it, it's classified as a wetted fire scenario. If it contains no liquid, it is essentially have vapor. It's classified as unwetted surface, unwetted scenario, which means that its sizing, its PSV sizing and relief load calculation is different from the wetted scenario. So, uh, for example, we have some vessel that serve as, for example, within this figure, serve as a compressor suction drum. This kind of vessel, as you know, compressor feed is essentially gas, and contains this vessel contains no liquid, and this vessel considered as unwetted fire scenario. And well, the second example is that when our vessel are serve as a heater. So let's consider this vessel is serve as a fuel gas separator for the heater, and this kind of vessel have no liquid within them, and it means that they just classified as unwetted fire scenario, and we should take a different calculation procedure to find their wetted surface area and consequently finding their relief load. I will discuss about unwetted in the next couple of videos, but in this case, I just want to focus on wetted surface. Wetted fire scenario. So let's consider this vessel. Do you think fire is applicable for this vessel? According to the API 521, if this vessel is installed above the ground and its level is less than 7.6 meter, fire is applicable. If it's not, so fire scenario is not applicable. So when you find, let's consider this vessel is installed, for example, 2 meter above the level ground, so the fire is applicable. And so the next question is that how to determine its relief load. Relief load in a fire case scenario equals the heat that the vessel can absorb per latent heat. So in this case, I will discuss how to find latent heat in the next couple of videos. I don't know, maybe in the next video within a high-C software. When it comes to the mixture, it could be quite challenging to find the exact value of the latent heat because, for the mixture, we have a boiling range temperature, and it could be quite challenging to find the exact value of the latent heat for mixture. So I just want to discuss about the amount of heat that the vessel can absorb. So if there is sufficient equipment within the refinery or the plant that we sizing this PSV for it, if there is sufficient equipment, we use this cost constant in SI unit. If it's not, we use this constant. So uh, so let's consider we have enough and sufficient equipment within our field. So heat that a vessel can absorb equals 43,200 times F, which represent environmental factor times wetted surface area powered by 0.82. So the environmental factor, you can find its exact value and the formula within the API 521, but just for simple analysis, I just consider that environmental factor equals 1. But this environmental factor depends on the material of the vessel and if it has any insulation or equipment around it or not. I mean, the thickness of insulation can affect environmental factor, but for simple analysis, we consider this as 1. So for the wetted surface area, it really depends on the shape of the vessel, or if the vessel is installed vertically or horizontally, this can be changed wetted surface area. So for vertical vessel, if its head is hemispherical, we use this equation for wetted surface area. If it's elliptical, we use this correlation. So let's consider this vessel is installed 10 meter above the, 2 meter above the level ground, and the liquid within this vessel is 10 meter from its height is 10 meter from the level ground, and the diameter of this vessel is 1 meter, and its head is hemispherical. So this equation is applicable. So uh, have to find the height within this equation. So height equals the level of liquid, which is 10, minus where the equipment is installed on the ground, which is 2, and it's equals 8 meter. And but according to the API, the fire can just affect vessel up to 7.6 meter. So we consider H as 7.6 meter. So let's substitute values within the wetted surface area formula, and diameter is 1 times this term, which H is 7.6 meters. So wetted surface area is 25 square meter for this vertical vessel. But what about distillation column? As you can see, distillation column are like a vertical vessel, but they have tray within its structure. But we should actually account for the liquid that are located on each tray, and we should consider wetted surface area for each tray, and finally find the wetted surface area for the distillation column. So distillation column, let's consider this is not a hard procedure, but let's consider this formula is applicable, and L represent the length of liquid, or height of the liquid, within the distillation column. So height of the liquid equals normal liquid level. Yeah, you should refer to your vendor datasheet document to find what is the normal liquid level for your distillation column, plus number of trays times the quantity of weir plus crest. And weir is, this is a vertical plate that installed the joint at the edge of every tray to hold the liquid on the tray, And we typically, to give you a general rule, in rule of thumb, we consider it as 2-inch initially, our basic design, plus crest. And crest is the liquid that jump over each tray or flow over each tray. And we, for this case, to give you a general rule, we consider this value as 2 to up 4-inch. And summation of this wire and crest, we consider it 4 to 6-inch initially in our basic design. So we have all the parameter, number of trays, normal liquid level. As I said, you should refer to your vendor document and find the normal liquid level within your distillation column. And the general rule, I have talked about how to find the wire and crest for your case initially, and you can find the height of the liquid within the distillation column. And as for this equation, wetted surface area, we have all the parameter. So you can find the wetted surface area for your distillation column. But when it comes to the horizontal vessel, it could be quite challenging, rather, in comparison to the vertical vessel. The horizontal vessel, so let's consider this horizontal vessel is installed less than 7.6 meter above the ground. So the fire is applicable, So wetted surface area for this orientation is classified into two types. And the wetted surface area equation is this, and D represent diameter, L is the tangent line to tangent line distance, and S, we need a correction factor in this case, which are shown as S. So if the liquid is above the center line, we use this for the S. Then S equals D times the quantity of pi minus R cosine of H minus R all over R. So if it's below the center line, we use this correlation. And H represent the amount of liquid within a vessel, not the liquid height from the level gram. We should consider how much liquid high is within its vessel. Okay, you know how to find that. I have discussed it about the vertical vessel. In this horizontal vessel is the same as the vertical vessel. So to clarify what I mean by the H within this case, let's consider that this vessel is installed, for example, uh, 10 meter above the ground. Okay, 10 meter above the ground, and its diameter is 2 meter, and the liquid within this vessel is 0.5 meter. So H within this case is 0.5 meter, you know, and we should analyze it. If look at this example, this vessel is installed 10 meter above the ground, right? And the fire case is not applicable at all. And the wetted surface area in this case is 0. Even though this vessel contains 0.5 meter liquid within it, and it's classified as the wetted fire scenario, but since it's installed 10 meter above the ground, fire is not applicable. So let's consider another example. Let's consider we have a vessel. This horizontal vessel is installed 5 meter above the ground, and its diameter is 1 meter, and the liquid level within this vessel is 0.5 meter, right? And if we let's consider if this fire is applicable or not. So 5 meter is less than 7.6 meters. So fire is applicable. But for how much of this liquid high is this fire applicable? So the liquid level within this vessel is 0.5 meter, right? And the vessel high is 5 meter. And summation of these two value is 5.5 meter. And since this is less than 7.6 meter, so for all of those liquid within this vessel fire is applicable. So you can, in this way, you can find how much liquid level is there within your vessel can be substituted within this correlation, which is this. In case all of those 0.5 meter can be substituted within this correlation for H, right? So we have discussed about the vertical vessel, distillation column, and horizontal vessel separately. To summarize what we learned, if the vessel height is less than 7.6 meter or 25 foot above the ground, the fire is applicable. And if it's not fire, it's not applicable. I will discuss, as I have initially discussed, about the relief load. Relief load equals heat that absorbed by a vessel per latent heat. And I will discuss how to find the latent heat, especially when it comes to the mixture. It could be quite challenging. It's not so difficult, but it needs to take a logical approach to find the latent heat for the mixture. I will discuss in the next video how to find the latent heat for the, actually, mixtures. I hope you found this tutorial helpful. Have a good time.